Okay, in this video, we are going to learn not just the intermediate value theorem, but also how to read and take notes on more advanced math topics. So this topic is the intermediate value theorem. And first, we'll just read the theorem. Let f of x be a function continuous on the closed interval a to b. Then for every number m between f of a and f of b, there exists a number c where a is less than c is less than b, such that f of c is equal to m. Now we'll go back and see what we can do to take this apart and figure out what's going on. So first we have a function f of x. We're used to that. This function is continuous on this interval from a to b. The notation here, interval notation, is something that I will link to. But basically what it is saying is that when a is less than x is less than b. So we are on an interval between a and b. You can see those on the x-axis down here. And from a to b, it's continuous. So there's no holes, there's no jumps, there's no breaks in the graph. Okay, then now that we've got those conditions set, for every number m, so that's every single, keep reading, between f of a and f of b. So since these are f of a and f of b, I know that these are y values. These are the outputs of the function. And they're not just any y values, but they're the coordinates. So you have a here, you have f of a here, and you have this point a, comma, f of a. I plug in a, I get out f of a. Then you have b here and f of b here, and that's this point right here. I plug in b, I get out f of b. Okay, so every point m is the y value. So m is some sort of output of the function. So m is an output of the function. And it's between this number that I got in when I plugged in a and the number I got out when I plugged in b. Okay, so for every single one of these points, so m is this line here, and you can move this line all the way up to f of a or all the way down to f of b. Could be any of these points in this area here. There exists, so there's some number c. So now here it says c is between a and b, so we can see that c is right here, it's an x value. So this number c doesn't have to be exactly here, but this number c is somewhere in between. Okay, and when we plug in c, we get out m. So f of c equals m. So we plug in c, and then we get out m. So again, what that's saying is, if you take any y coordinate that's between these 2 points, there was some x coordinate I could plug in to get out that specific y coordinate. So you take some number here and you look at your function, right? So that number m came out. That means there must have been some number c that I could plug in to get out m from my function. Okay, and what that's saying in our layman's terms of the intermediate value theorem is that you can't skip any. If the function is continuous on an interval, then none of those values get skipped. You can't just skip over a value if the function is continuous. If the function is here, and then at the end of its continuous interval is here, then there's some point every single y value gets hit between those 2 y values that are the output of the function. Notice it doesn't say anything about the area or the y values that are down here. It only speaks to the y values that are between those points that we were given on the function. So it only speaks to the y values that are between f of b and f of a. It doesn't say anything about the y values that go outside of that range. And so then once again, when we see something like this, we can't just copy these words and this image into our notebook. We really need